Today's lesson, difference between organic and inorganic compounds. Let us see some differences one by one. Organic compounds. Here, inorganic compounds. First point is composition. Organic compounds, for example, methane, ethanol, etc. Organic compounds consist of carbon, in which carbon atoms are covalently linked to atoms of different elements, mostly hydrogen, then oxygen, nitrogen, sulfur, phosphorus, halogen. So simply, organic compounds consist of carbon. On the other hand, inorganic compounds like water, sulfuric acid, etc. Inorganic compounds formed by any two or more than two elements. So, organic compounds, carbon compounds, basically carbon compounds. Inorganic compounds, basically any two or more than two elements. Second point is bonding. For example, methane. Methane is formed by covalent bonds. On the other hand, inorganic compound, sodium chloride is formed by ionic bond. Inorganic compound, water is formed by covalent bond. So, organic compounds are formed by covalent bonds. On the contrary, inorganic compounds are formed by both covalent and ionic bonds. Next point is solubility. Organic compounds being non-polar, suppose hexane, non-polar compound, it dissolves in non-polar solvent like ether, benzene, like this, but it will not be soluble in polar solvent water. Non-polar compounds, that is, organic compounds will be soluble in organic solvents. Non-polar compounds will be soluble in non-polar solvents like ether, benzene, but organic compounds cannot be soluble in water, which is polar solvent. On the other hand, ionic compound or polar compound will be soluble in polar solvent, but inorganic compound will not be soluble in benzene, like dissolves like. Organic compounds will be soluble in organic solvents like benzene, ether. Inorganic compounds will be soluble in polar solvent like water, but it will be insoluble in benzene. That is solubility. Organic compounds will be soluble in organic solvent, and inorganic compound will be soluble in inorganic solvent. Now, point 4, melting point and boiling point. Let us consider a compound ethanol. Its melting point is minus 97.6 degrees Celsius and its boiling point is 64.7 degrees Celsius, which is very low. On the other hand, inorganic compound sodium chloride, melting point is 801 degrees Celsius, boiling point is 1465 degrees Celsius. That is, melting and boiling points of organic compounds is very low. This is less than 350 degrees Celsius temperature. On the other hand, melting and boiling points of inorganic compounds is very high. This is more than 700 degrees Celsius temperature. This is the point related to melting and boiling points. Now, next point is point number 5, ignition. Let us consider methane. If it is burnt, then carbon dioxide gas and water vapor are formed. Here, no residue is obtained. But when inorganic compound, suppose zinc sulfide, is burnt, then zinc oxide is obtained as residue and sulfur dioxide gas is formed. So, on burning, organic compounds leave no residue, but inorganic compounds leave residue. On ignition of organic and inorganic compounds, organic compounds leave no residue, but inorganic compounds leave residue. Next point is point number 6, conductivity. Organic compounds are basically non-polar compounds. Organic compounds cannot form no ions. That is why organic compounds cannot conduct electricity. On the other hand, inorganic compounds, after dissociation, ionizes to ions. With the help of these ions, inorganic compounds can conduct electricity. So, regarding conductivity, organic compounds cannot conduct electricity, but inorganic compounds can conduct electricity. Next point is point number 7, polymerization. Organic compound like ethane, ethene. Ethene polymerizes to polythene. A number of molecules polymerize to polymer molecule, that is polythene. So, organic compounds undergo polymerization, but inorganic compounds cannot demonstrate polymerization. So, polymerization, organic compounds, no polymerization for inorganic compounds. Next point is point number 8, isomerization. For example, C2H6O molecular formula, a kind of organic compound. From this molecular formula we can get CH3CH2OH, ethanol. Another compound we can get ether. These are isomers of each other. These two compounds are isomers of this molecular formula. So, organic compounds can form isomers, but no chance for inorganic compounds to form isomers. No isomers for inorganic compounds, but isomers can form in organic compounds. Let's proceed. Point number 9, catenation. That has been discussed in the previous lesson in detail. Catenation is the property of carbon elements by which number of organic compounds become very high. Because of the catenation property of organic compounds, basically catenation property of carbon, but inorganic compounds cannot perform catenation. For this reason, number of inorganic compounds is very less. This is around 1 lakh, but number of organic compounds is around 80 lakhs. Difference between organic and inorganic compounds regarding catenation. Point number 10, homologous series. Organic compounds can be classified into some homologous series with common molecular formulae and functional groups. For example, alcohol, aldehyde, carboxylic acid, etc. But in case of inorganic compounds, no such homologous series. Inorganic compounds cannot be classified according to homologous series. This is all about differences between organic and inorganic compounds. Thank you very much for watching.